Right. The course code is DS5102 about the data modeling and management, and this is again a compulsory core course, which amount like 3 credit course. Hopefully, we are going to spend on about like 30 hours of lectures versus 30 hours of practicals on data modeling and management. And according to the syllabus, the topics range from basically on relational database management as well as NoSQL data modeling and management. And the other topics is around this one. So let me first discuss the content or the course description. So we will start today about looking at relational data model, and I hope you have already done this in your bachelor's. And this can be taken as kind of a review of the relational model concepts. And then we will go through the basics of relational modeling aspects, plus developing conceptual, then the logical to physical model. And then once you do that, we can also talk about physical implementation using SQL. And then we can also going to briefly talk about the database design and normalization aspect of it, right? And the other part of this course is the second topic, where we assume that in case you have not practiced it, this will be a new addition to use of NoSQL database management and modeling aspect, especially the concept of this, and also like different types of data models, because depend on the structure of the databases and the data that we have handled nowadays. The relation data model will not fit for everything. So we are going to discuss when to use and what are the different data models available. And also we will also give a brief introduction to database design, and as well as modeling aspect basically. Now, once we cover the two basic data model for both relational and NoSQL model, we will focus on especially the data distribution. We know that compared to old days where we have centralized database systems, now mostly what we have is distributed database management systems, where data distribution is one of the things that we need to discuss, because once you work with the data coming from various sources, so how do you put them in a distributed manner? And there we will talk about data sharding and replication model, as well as CAP theorem. Then we will also going to talk about the transaction processing, especially when it comes to the distributed model. So the concept mainly we are focusing is on distributed transaction processing concepts. So we discuss about ACID model as well as base model. And then once we discuss that, we are going to look at large scale data handling, especially big data and big data characteristics, as well as some of the API development and usage. What are the technologies we have nowadays to handle large scale data? Now, then after finishing that part, we will have basically on application level related topics, security, privacy, as well as legal issues, social issues, and also like, biasness, and then some applications and case studies. So that's the overall picture of what the course content is. Any questions? I would like to get the opinion of the audience. Anything that you want to clarify before we start?
Do we have any practicals, sir, for this one?
Yes, definitely. Like in previous case, all my courses, usually we try to have practicals, because this is like 30 hours of lectures and 30 hours of practicals.
Right.
So Yeah, we have to have
environment.
hands-on experience. So like I did in my previous course, the idea is once we have this, theoretical, uh, content, we will also have some hands-on exercises. If you want me, I can start from the relational data model where we can start with the MySQL and then maybe MongoDB. And if you are like to graph databases, we can go for Neo4j or something. Right now, I have not planned what we will have on NoSQL databases, but yeah, depend on the interest, we can have some practicals on those as well. But they're definitely for every topic, I'll try my best to have some practicals. So at least 6 or 7 sessions I'm going to have in parallel to a lecture. So it will not be a separate session, but mostly that. And then some of the work will be like a group work where I will assign you to some group work, and as a group, you are going to work on some of the topics. But before I move on any further, thanks for asking the question, Shanta. Like, I would like to know, like, how many of you are already familiar with the NoSQL systems, and those who are actively working in that area, maybe you can just raise your hands and let me know. Anyone is working actively in NoSQL?
Yeah, I have worked on Neo4j for a while, and plus MongoDB. So these are two areas that I worked on.
Okay. So
actually, I'm working on Cassandra, MongoDB, and Redux for almost 5 years now at PSN.
Wow, right. So that's great. I think it's great addition, because like so for my case, although I have touched upon like these systems, mostly it's theoretical and maybe the basics. So hopefully maybe I can put some of you in groups so that you can educate the others on maybe real use of these databases. So I think it's great to hear that some of you have already worked in this area. How about Gunaratna? Like, what was your experience on this?
So actually, that I have experience in this NoSQL database like Cassandra, MongoDB, and also that distributed databases. But my case actually that in this big data data modeling, do you in this course do you touch these Spark, Hadoop, these kind of systems?
Definitely theoretically, but let's have some practicals as well so that we can, everyone can work on this. Yes, theoretically, yes. Let me have put some practical sessions so everybody can be familiar with those systems. But anyway, I mean, remember that I'm also preparing, sessions. So you have to give me some time on those as well. But definitely, that's the aim, because these are like master level, courses. And then we need to have, sessions as well. Planning is like in some cases, I will arrange some guest sessions where like selected individuals will take care of some of the topic as well.
What about the infrastructural requirements, like for these large scale data, like big data and Hadoop and all that? Do we need to set up our laptops?
Mostly the plan is to use some cloud-based tools or the sources available, and hopefully I think if you have a browser connectivity, that would be enough in most of the cases.
Right. Okay.
My plan is not to rely on our own laptop, so I don't think it's a good idea.
Yeah, unless we do some Docker or something like that, we always have problems.
Yes, exactly. So yes, I will come up with a concrete plan on those, and thanks for letting me know everything. Right. So I hope you got the idea of what exactly we are going to have, and this is one of the basic modules in the data science toolkit, and which will give you the basis that you need for the other modules as well. Right now, having said that, let me go to the aim as well as objectives of the course. So the originally what we need to emphasize on the emerging data models, like you have already mentioned, some of these databases already have, and then also the idea of discussing what traditional requirements what we had, and then what actually has changed within previous years, which emerge of the free textual data, especially non-relational database types, especially semi as well as semi-structured as well as free data that we have, and how you can actually handle these, especially for data analysis, right? So keeping record is one of the prime objectives, especially before we analyze the data, we have to put into a form where we can keep and efficiently search, summarize, aggregate, and slice and dice the data that we want for analysis. Right. And the indebted learning outcomes, so the ILOs are put it like this, especially applying these modeling and management concepts. I'm not going to fix on one particular modeling technique, although I will present very traditional way of theoretical presentation on, since I'm coming from the academic way. You are free to use your own techniques, since some of you are really work in the industry, and you have spent a lot of time on those too. So you can always suggest me when I'm presenting something, alternative ways, the recommended ways, because you have more practical experience than myself. So I acknowledge that, and I hope those who are learning and those who are beginning, that will be helpful, sharing your knowledge while we discuss some of the topics. So some of the times the theory that we will discuss might be outdated, and basically my way of teaching is usually I select a textbook and follow it all through the flow of the textbook. So you are always free to share your ideas as well as add things so that others can learn from your experience. So keep this in mind. So this is not one way, and I don't think now traditional teaching works, since we everybody know that there are other forms of teaching and learning, which I am planning to use in this module as well. Right, but today's class, anyway, I will go through with some of the material that I have already prepared for my previous courses. Where necessary, we will spend time on, because it's a review of relational databases. Right. So one aspect is like the design, and also discuss use of relational model as well as non-relational models, and their various characteristics and the requirements. The point here is like, depend on your requirements. I think you should be able to decide which data model is more suitable for a problem at hand, right? And then we will also going to touch the concept of big data, security, privacy, governance, these ideas. And as the request, let's look at some of the big data, technologies as well. Right. And then finally, we are going to look at like the importance of data engineering, data visualization, which actually connects to the data science aspect of this. So with that, I hope we can, connect the modeling and management concept of the module. Right. So all this information actually I have taken from the course description, and what the recommended text for the time being is this. So these are the 4 recommended textbooks recommended in the course design. And whenever I use some other text, I will let you know what additional text that I'm actually using. So if you're a beginner and if I started look for some textbooks to start with, so you can follow some of these. Right. Then let's move on our review topic. My today's review, I'm going to talk about basically what database starting from the very beginning. I will go through the conceptual design of relational databases, the logical modeling and physical modeling. And if the time permits, I will also going to touch upon normalization as a review point for relational database system. Right. So having said that, let me start from the defining the databases, right? And especially when you talk about the data, we talk about some known facts, and then we have an implicit meaning. And databases, we normally talk about as a collection of related data when it comes to a relation database model. And that represents some aspect of real world, right? And especially they are logically organized. Now, when we talk about the database management systems, we are going to talk about software packages or the systems that we can use to create, manipulate as well as basically maintaining computerized databases. So we already know from the relational database or relational modeling from your previously, we can define the database, especially we can talk about the types of data as well as different types of relationships. And then we also have operation for creating database, especially the processing as well as storing. And then you can actually manipulate the database. So when we take database management software with the data, we will say it's the database, system. Right. Okay. So the next thing that I would like to discuss about the, how the database system is look like, especially how the data as well as users are interact in a database system, right? So in this diagram, remember so I forgot to mention in the beginning, for this session, I'm actually referring the text coming from Navathe's book, which is the traditional text which mainly focus on relational database systems. The reverse version is version 7, which also treated NoSQL databases as well. Right. Okay, so as I told you earlier, like when you look at database system, that means the overall interaction from the users. When we say users, there are different types of users are involved in the databases, right? For example, starting from operational level users, we have managerial users, as well as those who really work with the databases, the programmers who develop this one. So how they interact with the database software, especially database management system software, is using application programs or the queries, or sometimes we call with prepared statements. And within the database side of it, usually we will have metadata, that means the data about data, as well as the actual data, which we call stored databases. So once the user actually make the query, so that query is converted into accessing the data. So for that, we have to have softwares to process the queries or the programs, and then we need software to store data. Right. Now that we talk about the database system software, now I would like to discuss my discussion on database model as well as database model operations. Right now, remember, this is related to both relational and non-relational data model. But in generally, when you say a data model, what we mean here is we are going to talk about a set of concepts which describe the structure of the database and what constraints are there for data base to obey, and the operations of the data model, which describe how you may actually retrieve, update, using the concepts of the data model, right? So simply, when we talk about these operations are twofold. There could be basic operations, which creation of the data, which manipulates the data, and so on. At the same time, it should also support, right, the user-defined operations. Okay, now that we have discussed about the data model and data model operations, now let me switch to my discussion of different types of data models, at least looking at the high-level view of the model, right? So starting from the conceptual level, so the conceptual level means the high level of the data model. Now, when you look at relational data models that we will use, for example, integrated relational diagrams or UML diagrams, which we can create, conceptual level data model, right? So this actually could be used to see how many users can be seen, right? And then once you have that, then you can have physical data models, which you can use to how really you are going to store the data in the computer. And then you can also have implementation level data models, which basically in between two, right? So these are the models that actually we are going to talk about when it comes to, databases. So when you're defining databases, so we define the schema, the term schema we use to say the description of the database and also the structure and the constraints. So when you talk about these schemas, we can talk about the three levels, right? So the three schemas are known as what we call internal schema, right? And then we can talk about, let me just go back to, yes, once we have conceptual level, we talk about we discuss the conceptual level databases, and then we discuss the schema. And then I want to discuss three levels of databases. Right? So the three levels are, we can talk about internal schema, which means the physical storage structures and access path, especially in relational data model, we can talk about the indexes, and then conceptual schemas, which we can use for conceptual level schemas, and then external schemas that we call external level, where we can describe different views of the data. So these can be in different levels, right? So which we can actually represent in a diagram like this. So the internal level means like when it comes to storage level, how the schemas look like, and then how different external views are. Now, for example, when you say external views, for example, if you have operational level user, then that external view, and let's say managerial level user, that external view is slightly different, right? And then you have a conceptual level schema as well. Right. So when you want to mapping, you need to transform these. You can transform external views to map into conceptual level and conceptual to internal storage structures. Now, the one of the main ideas that we have discussed in the beginning is when we talk about the data is the data independence idea. Now, the idea of data independence is when you define the lower level, right? And that lower level changes could be made it to high level. Only you can actually change only the mappings. And the idea is high level themselves will be not change, right? So the application programs that you develop will not be changed. Now, for example, in relational databases, we can change, for example, index structures which will not, affects the upper level of the database, right? So that idea we call data independence, which actually helps a lot, especially when it comes to data handling. Right. Then we have different types of databases are there, and with the database there will be different utilities as well. So let me next discuss briefly on database components available in database management system software, right? Now, you know that the database management system will be a very complex system, and which, when you look at it, there are like various users interact with the database, and they are using different ways to interact with the database. Now, for example, if you use general users, operational users, they have a set of predefined transactions. We normally call sometimes CAN transaction. That means they are well designed, well tested interfaces. Through interfaces, they are going to interact with the database. Now, then there will be some developers, we normally call application programs, then they will use some application programs to interact with the database. Then there could be some casual users, especially let's say the management staff, sometimes with some technical background, they can directly interact with the queries. So they can, for example, when managers want to make a decision, so they are not, if the questions are not previously developed, maybe you have to use a query to extract the data. And then there are like people who works as the administrative staff who are responsible for the databases. We call database administrative staff. They might use DDL statements or privilege commands to access the data. So the query, when it should transform into such a way that could be interact with the stored data set. So you have a different ways of executing these, queries. Now, apart from this, there are like several other system utilities are also used. For example, we have loading data, backing up, reorganizing, report generation, performance monitoring, and other functions. So there are a lot of database system tools, utilities you use. Right. So the final discussion to the databases. So we can talk about very traditional databases, and then we have emerging databases which include these NoSQL databases. Or we can talk about databases which interact with the single users and multiple users. Databases we can classify based on whether it's a centralized or whether it's distributed. And sometimes we can also discuss the databases based on the cost. Right. Okay. So now that we have discussed about the, briefly on databases and database management systems, I would like to discuss about database design and implementation, process. Now, when you're going to talk about the database design aspect of this, so there are various stages are there, right? And I think it's not a very fixed one. It depends on what kind of databases that you have. But this is like typical, right? Database design phases. Especially we talk about these in relational database models. So the first phase of the database design and implementation process, we talk about the requirement collection. So when we talk about the requirement collection, we mean that both data requirement as well as the processing requirements. Because data requirements we handle in database levels, whereas data processing requirements we handle with database application development aspect of this. Then we have a conceptual database design. And usually when we talk about the conceptual database design, it will be independent of what the database management system is. Now, this could even be applied whether you are going to use SQL or non-SQL. So that initial stage might be conceptual data. And in the database application side of it, if it is a transactional database, so you have to think about the transactions and its application design. Now, once you have the conceptual database design is ready, then you have the choice of a database. So that depends on a lot of other factors, which I'm not going to discuss, but some of them are like maybe based on what expertise you have in the organization, or depend entirely on whether you want to go with the emerging technology. So it depends on number of things. Now, once you choose, the choice is made on different database, then we can talk about the model mapping. So that means we can go from logical schema to view design to physical design, internal schema design, and so on. And final one is basically system implementation and tuning, where we actually can use the data definition languages, as well as we can use them to work with the system. Right, so that is typically what you might see in database design. Right. Now that we have discussed about this, so let me briefly talk about the next part. So the idea of the next part is we are now going to talk about the data modeling, which is what the topic is. So I will spend some time on this topic, right? And hopefully today's group work will be based on this aspect of data modeling. Especially today, my focus will be on relation data models. Now that we have talked about the data modeling aspect of this, So as we have seen from the previous slide, that about the first step would be that you collect your requirements. So that comes as different way, but mostly we can think it as kind of a description about your data requirements, especially when you're focusing only on the database aspect of this. So let's see a typical company environment, and let's start with the small description on the data requirement. So this is actually the description I'm actually taking from the Navate's book. So that describes about a company, and in company there are some employees work on different projects, and they also assign into different departments. So in this description, for example, we will have different data requirements are there, especially about the employees, their work in departments, the projects that they were involved in, as well as their dependents. All this information we want to keep track. So let's assume that this is where we are going to start with, right? Now in relation modeling, especially in the conceptual model, there are like many modeling techniques. But let me first look at the ER model, which is the basis for the relational data modeling. And then also some, I know they use even other modeling techniques like UML for the same thing, right? So let me present the ER model. So you can see how many of you are familiar with all the notations. So I don't think I need to go through these, because I think you have covered at some point, isn't it? Are you all familiar with these notations? If so, please raise your hands. So what I presented is some data requirement, database description, plus ER model. So today we have about 22 in the class. Now, some of you have already raised your hands. Only 9 others are you. If you're not familiar, please don't raise your hand. So I'm just waiting. Keep on raising your hands, and then I'll talk to the others. Okay, Rahal, so what is your background?
It's going to database activities, so database administration.
Okay, so you are familiar with these notations, right?
Yeah.
Okay, yeah. Siraj?
Yes, sir.
Are you familiar with the notations in this graph, or is it new to you?
No, I'm familiar. I'm familiar.
Okay, yeah. So I think everybody is familiar, so we don't have to spend time on that. Thanks. So you can lower the hands. So as a review, so I'm not going to discuss these ideas. The idea is I'm assuming that you are familiar with the ER modeling technique. So I'll have a small work at the end of today's session, so that we can see or you can review what we have done, right? And then as the next step, I would like to also going to discuss the extensions that proposed for entity relation model, which is called ER model, right? So let me move on to that one, and let's discuss whether you are familiar with this. Again, remember, there are like many modeling techniques. So are you familiar with this notation as well? Those who are familiar, you can raise your hands. Those who don't, you can wait. Okay, Hassan, Fasal, are you familiar with this notation or is it new to you? If it is, you don't if you don't remember, you can still raise your hand if you have learned, and then that's okay. But if you are new to this, maybe then we have to spend some time.
Yes, I have done these things, but
Okay.
yeah.
Yeah, maybe you
some,
can
some of them
refresh.
I have to refresh, but it's fine.
Yeah. So for example, in this one, we represent specialization. Again, remember, sometimes you might actually use UML notations. That's perfectly all right. But this is like we call, you can lower the hands. Thanks, everyone. So in this one, we have employee entity type, and then we have three specializations, secretary, technician, and engineer. And these are known as distinct. The D here specifies the distinct specialization, which means when you take a particular employee can be put into one of these specializations. So how it is specialized will be put within these double quotes, which means that's how you can see. The arrows indicates actually going from superclass to subclass, and this job type is what we use to specialize employees into secretaries, technician, engineers. So all the inheritance idea will work here as well. So for example, if you take secretary entity type will inherit all the attributes from employee, and there is type is speed actually only related to secretary entity type. Okay. So I think that's good because we don't have to go through everything. And then similarly, there are other ideas like we can talk about overlapping. For example, in this one, what this means is the part can be specialized into manufactured part or purchased part or both. The O indicates that it's a overlapping, right? Similarly, the next one will be what you have union categories. That means in this particular case, we have sometimes when you are purchasing a vehicle, you might sometimes taking a loan. So the ownership of the vehicle could come from a person or a bank or from a company. So that's what we call the union category. And at the same time, so the car and truck is also the same. So from that, you can have come with a registered vehicle. So these are like some of the enhanced entity relationship diagram concepts, which you can also represent using other, the representations. Okay, so once we do that, then we talk about the logical representations. Now, for example, our previous ER diagram can be put into this form. So this representation usually we use when we have entity relationship diagrams, or the entities will be transformed into what we call relations. So in this particular case, you will see a couple of relations: employee, department locations, project, work zone, and depend. So depend on what kind of an entity type. Entity types will transform into relations, and depend on the relationship type, whether you have one-to-one, one-to-many, or many-to-many, then you might create some new relations. For example, if it is a many-to-many relationship, usually you create a separate relation to represent that. Now, for example, here, works on relation is something similar to that. Similarly, sometimes if you have double overs, which requires that you have multiple values, multi-valued attributes, then you can also create separate relation. So I think these ideas also you might be familiar with. So that's the logical design of the database. Now, once you have this, the next one is actually creating the tables, hopefully using a language called SQL. Using SQL, you can create the tables, and then you can define data types, and you can define the other constraints like primary keys, and also like secondary constraint, which may be you can refer foreign keys, right? So these can be stated, right? So in this example, so here you will see the logical schema, and then the physical schema as kind of a one database instance with some data is filled, right? Okay, now just to talk about the rules of this mapping. So usually when you're mapping, you are going to focus on a couple of things from ER to relations. So you normally start with mapping all the regulated types. So regular means you have clearly defined a primary key for that entity type. But sometimes you cannot have separately, uniquely access. For example, in previous example, we have a dependent and independence. They don't have a primary key. So you have to have the relations through the employee entity type. So which we call weak entity type. So weak entity type also, we will create a separate relation, and then we have identified relationship coming from the connected entity. Then you have mapping for one-to-one, one-to-many, and many-to-many relations. Then you have mapping for multivariate attributes, in-array relationship types, and then finally mapping specialization and generalization, and then finally mapping of union types. So those are like some of the steps that you should think about when you are converting relational model algorithms to mapping into a logical diagram, and then you can convert into a physical diagram. Right. Now that you have already learned this, right? So I have a small, question, which I want you to convert the ER diagram into relations or the table structure, right? So my first question is on specialization. So let me go back. So I will give you some specialization. And okay, tell me like what are the ways of converting this into relations or tables? So here is my first question. So I earlier described this. We have an employee entity type. Then we are going to specialize as secretaries, technicians, and engineers. So how are you going to convert this, right, high-level modeling diagram into logical diagram, like which creates the relations? Any ideas we can openly discuss?
So you'll have a main entity called employee, and then you derive from that and create extended version of secretary and technician. So you can have a type for those.
Okay. So if you are creating, let's say tables, how many tables you are going to create for this? Are you going to create a one table, or are you going to create like table structure? We have four tables.
It'll be a 4 table.
4 tables.
Okay. Those who say you can create one
2
table as
tables.
well.
We can create 2 tables as well, based on the access criteria. So if the access is based on employee number, then we can go with 2 tables, because the extended information is only limited to few of properties like typing speed, T grade, and engineering type.
Okay.
So my idea is actually we can create 4 tables, because that using or we can create some 3 tables with all the employee data. But if you do this kind of thing, that data replication, the data, that same data repeating is there. Therefore, that we can create 4 tables instead of that repeating this all the employee details.
Thanks, Gunratna, for the feedback. I think I totally agree with you. So depend on the situation, you can create a single table. That is possible, one choice. So that means for all these 4 entity types, you can create one table, or you can create 3 tables, or you can create 4 tables. And this depends on exactly your requirements. There's no single solution for this, right? So let me present you like some points. For example, now remember, this is a distinct one. The D stand for distinct, which means like if you take a one particular instance, it could be in any of those, like secretary, technician, or engineer, right? So if you have in this manner, then actually you can create 4 relations like this. One table for having all the employee details, but to record of if depend on the job type, you can see here we have a job type which connects the other tables, which keep only information about their typing speed or the technician grade or the employee, depend on what job type is. So that is one way to represent this one. The second one is actually you can also put only secretary, technician, engineer. That means only 3. But if 3 is allowed, only if all the instances can be classified into this one. Whereas in this example, you have a single line. Single line means there could be some places where some of the employees are not belong to any of these. But let's assume that you have a situation like this. The situation like this, all these vehicles can be put into either car or truck. If that is the case, you can forget about this, the superclass vehicle, and you can create the relation for car and truck only. So in this case, it's possible when all the instances can be classified into cars or trucks only. Right? And then final classification is like, instead of creating the choices, you can have a single relation where you have everything together, like employee or the attributes, plus you can have a job type. Depending on the job type, you can have type, speed, technician grade, and engineering type. So these are like 3 possibilities. But as you said, it depends on what exactly you want to do with the data and nature of the data sets. Now, for example, if you have a lot of redundant data, maybe then you can separate it out, right? And if you have, very limited data, then yes, of course, you can put into one single relation. So it's up to you to decide. And there are three possibilities we have discussed. So you can have 4 relations, or you can have 3 relations, or you can put into one single relation. Actually, we can debate about this one as well. But I guess you understood the idea, right? Yes, agreed the possibilities?
Yes, sir.
Okay, thanks. Now, since now we have discussed these ideas, you can see we have now discussed up to the modeling concepts, especially in use of entity relations, and also enhanced version of entity relationship diagrams. Right. The next part I would like to discuss about the normalization aspect of this. This is the next thing that we want to discuss under the review, right? So under the review, I would like to discuss about what are the normalization aspect of the relational data model. Right. The first thing that I would like to discuss about the functional dependencies which available. Now, functional dependency idea that we have discussed is when you have a same set of attributes in one particular attribute, and when appear in the same set, if you can identify it, it can functionally determine another set of attributes, then we can say they are functionally depend on each other. Now, for example, let's say we have attributes X and attribute Y. For same set of value for X, if you can notice the same set of value for Y, then we can say, okay, the value of X can determine the unique value of Y. Then we can say Y is functionally determined by X. So that is what we call functional dependency. Now, this idea we can mathematically represent by drawing an arrow. For example, we can have X arrow towards Y, which means that we can functionally determine the value of Y by using X, right? So what it means for the say any two records or the tuples, for same set of values, you will observe the same set of values for Y as well. Right. So once you talk about the functional dependency, let me discuss some instances. So these instances actually coming from the same company database. For example, social security number, it's like our identification number. Using that, you can determine the person's name. So that we can say, okay, we can say employee name can be functionally determined using social security number. So what it means is whenever you have a same social security number, you have the same name. Similarly, let's look at the second one. The second one, you have a curly bracket, and your right hand side, we have project name and project location. So what it means is using the project number, you can functionally determine project name and project location. Then the third one, we have the social security number of an employee and the project number. So using the two, we can functionally determine how many hours particular person works on that project. So this is some example for identifying functional determinant. Right, now let's briefly go through the type of normal forms usually we talk about. Now, the first normal form we talk about, it should disallow any composite attribute, multi-valued attribute. Basically, we should say that the value should be atomic, right? If there's attributes with the values tuples are non-atomic, we can say that the relations are not in first normal form. So similarly, that normalization, the normal forms, which indicates the quality of these relations. So the idea is we need to improve the quality of the relations. So the next one that we can actually talk about is the second normal form. But okay, before that, let me give you an example. So for example, here, now what we have is a department relation, and we have a department number, and this underlining, it will indicate that it's the primary key. Now, when you say a primary key, usually we using primary key, you can functionally determine all the others. So that's why you see an arrow here from starting from department number. You can functionally determine the department name. Similarly, you can determine the department manager social security number and department locations. So if you put some values for these, so department name, for example, you have research administration headquarters. The numbers are here, some manager description are here, and some department location. So if you look at this carefully, you have multiple values which will not consistent with the first normal form. If you have multiple values in the first normal form, that we will say that, okay, this is not in first normal form, which is the zeroth normal form. Therefore, this is a violation, so which means you have to break it into 3 pieces. So you can see here department locations. They are put into a single location, and then they have replicated the remaining attributes. So this is about the first normal form. And similarly, another example. Now in this example, what you see here is we have employee project details. And once you have employee project details, here you have the project details, the project number and number of hours are working, we put it in there. So the values are not, atomic. So we have the data set is in zeroth normal form. So to make it the first normal form, you have to break the 2. So you can see here, the suggested editing is here. We have employee project 1, which we have social security number and employee name. Similarly, we have employee project 2. So we have a social security number, project number, and number of hours a particular person works for the project. So you separate out. So once you have separated out, you will have a unique value for each of these. So then it will be in first normal form. Now to summarize, what we discuss here is the first normal form. So the value should be atomic, right? Right. Now let's move on to second normal form as well. Now in second normal form, we are going to talk about these functional dependencies that we have discussed earlier. Now the second normal form says that all the non-prime attributes, all the non-prime means all the attributes which are not belong to any candidate keys should be fully depend on the primary key. So let me give you an example. Now here, in our previous example, that means our company database, social security number and project number both can be used to determine number of hours a particular person works for a project. So let me go back to this data set. So let me go back to the data set and then I'll come back to discuss this, right? So here what we have, give me a second, right? So here what we have the data set. Right, here is the outline. Now let me now explain. I think then it will be more clearer to you what exactly we are trying to discuss it here. Now what I said from earlier is that, okay, social security number and project number. So social security number and project number, can be used to function determine the number of hours, right? We say this is fully functional dependent because if you are trying to remove social security number or the project number, so that relation will not hold. But let's say you have social security number and employee name. Now let me take this one. So usually when you want to represent something like that, so we can say, I can draw something like that using both social security number and employee name. Let's say we are going, sorry, we have project number. Social security number, and let's say we have project number. We are going to functionally determine employee name. So the point here is still we have a relation from social security number, employee number. So when we have social security number and project number both, even by removing project number, still we can find a relation between social security number and employee name. So because of that, we will say it's not fully dependent, right? So remember that is the idea of second normal form. So simply you can, to summarize the second normal form, if you have only one attribute in the primary key, you don't have to think about the second normal form, but only if you have like multiple values which create the primary key. So when you have multiple attributes, so when you talk about the function dependency, so all the non-prime, that means all the attributes which are not part of the primary key should be fully functional depend on, right, the primary key. So that's what we need to discuss, right? Okay, so let me give you some example. So in the next example, I'm going to give you, the second normal form. So just look at the part A from the previous one. So we have employee project, and then can be used to determine the number of hours. And then if you have employee name, only social security number is going to function determine employee name. Using project number, we are going to determine project name and project location. So that means this is a violation of second normal form. Now, second normal form, what we say is the primary or the non-prime attributes. Non-prime means not a part of the primary key. That means hours, employee name, project location. They should be fully depend on the primary key. So you have two relations. But you can see here, employee name is only related to social security number only, which is partial dependency. Similarly, you can see project name and project location will be depend only on project number. So again, partial dependency. So that means we can say that, okay, these relations are not in the second normal form, right? So since it's not in the second normal form, so we can make it, a second normal form by breaking the two partial dependencies. So the two partial dependencies are partial dependency 2 and partial dependency 3. So we can break these two. We can take social security number and employee name as a separate relation, and project name, project location together with project number as another relation. So original one with left only with hours then. Right, any questions up to this point? I hope you have already done these things, but yeah, I thought of covering since this is the review. Right, third one is called we can talk about transitive normal, so third normal form. It says transitive functional dependency. Okay, what it means is sometimes you can find functional dependencies based on X. You have arrow Y. So that means phi function determined by X. So if that can be done through another attribute, this is called transitive functional dependency. So if I go back, now in this one, you can see here, right? There are some situations where we can, for example, this one, you can see, this is called what we call transitive dependency. Transitive dependency means what it means. So this function is, we can have price, the area, we can define the price through the area. So this is not, put into any of the primary key. So therefore, this is known as transitive functional dependency. So we need to break this. So to break this, so we can actually, take the area and price out, and we can create it as a separate relation. Right. So that's about the third normal form. Right. So with that one, we can finish working on the review the theory of this. So as the next step, we are going to talk about couple of group works on the same things that we have discussed, starting with the simple database description. Let's create a conceptual diagram, for example, using ER diagram. Then let's convert into a logical diagram. And then finally identify all the relations, right, with the information about primary key and foreign keys. That is enough. And make sure that all these, the relations that you create are in the normal form, right? Okay, so let's have a 5 minutes break. And once after the break, we'll start the group work. So I'll put you into groups, and then I will give you the problem description. And then for the remaining half an hour or so, you work on the problem and make a group submission.
So don't you discuss Vice code normal form?
Sorry?
Don't you discuss Vice code normal form?
Okay, if you want voice code also, right, let me discuss that one as well. So usually when we talk about, there are 5 normal forms we normally discuss. And what I describe is the first normal form. So there's another normal form which commonly used, which we call Boy's code normal form, which you have a unique relationship, which you can see in this example. So in this particular case, then we have Boy's code normal form. If you have a functional dependency X into A, which means A can be functionally determined by X in some relation R, then we will have X is a superkey of R. So sometimes the problem will be is these relation will be in third normal form, but not in what we call Boy's code normal form. So the idea of this is we can go for Boy's code normal form when we have relations. So let me take an example of this. So let's see this particular example. In this example, you see that there's a teach relationship. In the teach relationship, you will also have student, course, and instructors. Okay, simple question, like what functional dependencies you can observe here? Yes. Can you identify any functional dependencies? Remember the idea of functional dependencies. If you can identify the same set of values, so particular set of attributes. And for that, if you can observe the same set in the other relation, then you can use functional dependency. I will repeat my question. Now, given this teach relation, we have three attributes, three fields. We have a student, course, and instructor. So we have students, they are taking courses, and then there will be a course instructor information is given. Now the question is, like, what are the functional dependencies we can identify here? Now definition of functional dependency we discussed earlier, where you have same set of values in one relation. And then if you can identify the equivalent set from the other relation, then we can say we can functionally determine each other. Okay.
There's a relationship between student and course, and there's another relationship between instructor and the course. Right?
Exactly. Yes. So the first one I will revise a little bit. So the one relation, the first functional dependency will be student and instructor. Actually, it will together with the course. So we can use both student and course can be used to functionally determine the instructor. That is one. The second one is using the instructor, right? With the instructor, we can functionally determine the course. Now, if this is the kind of functional dependence that you can see, we normally say that this is in third normal form, but not in Boy's code normal form. So therefore, we need to break this. We need to break this. So when you are trying to break this, there could be multiple possibilities, right? So let me give you the possibilities. So if I'm removing this one, so yes, if you go back, right, there could be multiple possibilities that you can have for T. Now we need to break this, our previous functional dependency into two relations, and these are the possibilities. First one, we can say, okay, this is the first one. We can have student instructor and student course. So the both will create the primary key, and here will be student course. The second one, you can have course instructor and course student. The third one, we have instructor course and instructor students. Right, now the problem is if you try the first two, you can try this from the previous example. And when you join, it might create some tuples which not actually the real data. So it artificially creates some data with the first two relation. So the out of all the three, these possibilities, only third one will not generate any spurious tuples after join. So to remove the problem, so if you want to achieve the Boy's code normal form, you have to break the previous one as instructor course and instructor student in this form. And that's about the Boyce code normal form. Okay, good that I have discussed about up to Boyce code normal form. So usually recommended practice is at least you look at your relation as third normal form or Boyce code normal form. But in there are like other normalization form as well, fourth normal form and fifth normal form, which normally we will not discuss in practical aspect. They are special cases. Okay, anyway, thanks for the question. I think we have covered up to Boyce code normal form. So let's have a small break. We have 2:31. Let's meet again 2:40. We'll have a small break. And 2:40, I will be put you into groups and we'll work on a small problem on relational data model. Thanks. Okay, let's start.